So today we are talking about fluidized bed dryer. In principle, when we are talking about construction or working, before that we will see what is the exact principle of this fluidized bed dryer. Generally, hot air is passed through a perforated bottom of the container containing the granules to be dried over here, and the granules are suspended in the air stream and rise from the bottom, and this condition is called as a fluidized state, isn't it? So hot air surrounds each granule to dry it completely, and therefore the materials or granules are dried uniformly. So this is the overall principle of this dryer. In construction part, or maybe when we will see the construction, again we will go back on a principle of this particular dryer. So in construction, as you are observing in the diagram, it consists of steel shell of cylindrical or rectangular cross section, then a detachable bowl which has perforated bottom is placed on the bottom of the dryer, isn't it? So this is a detachable bowl. This is a maybe cylindrical or maybe the rectangular shape uh, cross section is there, and it is used to load and unload the materials, isn't it? Whatever the detachable bowl is there, that is used to load and unload the materials, and generally this bowl is used to place the materials to be dried. जो भी आपको ड्राई करना है, that you have to keep in that particular bowl, and you can fix it on fluidized bed dryer. And fan is mounted on the top to circulate the hot air, isn't it? So this fan mounting is there, so whatever the hot air get generate, so for circulation of that particular hot air, the fan is installed in this fluidized bed dryer. And the fresh air inlet, as you are observing, the pre-filter and the heat exchanger, these are connected in a series to heat the air to the required temperature. So we can set the temperature over here, and this is the inlet, then this is the air heater, and this is a filter bag. These are the arranged in a such a way that we can maintain the proper temperature over here, or we can fix the temperature on a panel. The temperature of the hot air and the exhaust air, here monitoring facility is there, whatever the hot air is there and whatever the exhaust air is there, so that temperature gets monitored in throughout the drying process. And bag filters, these are placed on top of the drying container for the recovery of the fines. So these are the filter bags, isn't it? So we can collect the material over on these filter bags. The airflow is adjusted by means of the recirculation control. So as you are observing, this is the recirculation control, so we can monitor this, or we can optimize this in fact. Then as you are observing, that one more point is there, that the airflow, isn't it? The fabric bags, these are provided to prevent the passage of the fine particles. So that is the reason all these filter bags are placed over here just above the detachable bowl, and this is the fluidized solid. Clear this construction part. And when we are talking about the working, exactly what will happen in working, the wet granules to be dried, these are generally placed in this detachable bowl. So this is a detachable bowl, we have to place whatever the material we have to dry. Just consider the wet granules we are drying over here. The bowl is inserted in the dryer, then fresh air can pass through a pre-filter, which is then heated when passing through a heat exchanger. So whatever the air inlet is there, isn't it? So this air will come over here, that gets with the help of air heater, temperature of that air will get rise and will become the hot air, isn't it? So once this hot air gets circulated, or that hot air flows through the bottom of the bowl, and at the same time the fan starts to rotate, so the air speed increases gradually, and when the velocity of the air is greater than the sedimentation rate of the granules remain partially suspended in the gas stream. Are you getting this point? So after a specific times, a pressure point is reached in which the friction drag on the particles is equal to the force of gravity. So obviously, the granules that rise in the container due to the high gas velocity of maybe around now 5 meter per minute, or maybe we can decide the velocity in meter per second, or just you can keep in mind that the granules rise in the container due to the high gas velocity, and again that granules will become fallback. So this condition is said to be the fluidized state, and the gas surrounds each granule to dry them completely over here, isn't it? So these granules will get dry completely because of this hot air, and the air comes out of the dryer passing through the filters in the bag, and the entrained particles remain adhered to the interior of the surface of the bags, and periodically the bags are shaken to remove the entrained particles. So obviously the residence time for drying is approximately 40 minutes over here. If you see the actual drying time, that is around 40 minutes, and you can compare with the other dryers as well. And another one point you can add over here, that the materials are sometimes left in the dryer to reach the room temperature. So the bowl is removed for unloading, and the final product, whatever we are getting, that will be the free flowing product. So in this way, you can mention the overall working pattern of this fluidized bed dryer. Whatever the material you have to dry, you have to take in bowl. With the help of the inlet air, this air becomes hot, and this hot air gets recirculate here on this particular bowl material, and the particles will become dry, and that you can again remove it, because this is a detachable one. So advantages we can quote that it takes less time to complete drying as compared to the other dryer, and drying is achieved at a constant rate, and handling time is also short. So that point you can say over here. Clear this particular point? Any doubt over here in case
No,
of yeah, in case of fluidized bed dryer? Then in disadvantages, what we can say? Many organic powders generally develop the electrostatic charges, isn't it, during the drying? And to avoid this efficient electrical grounding of the dryer is essential. And also the chances of attrition of some materials resulting in the production of fines. Because of the attrition, there are the chances of clogging, or maybe we are not getting the actual exact material, whatever we have loaded on the material or loaded on the dryer. And in advantages, same points, it is available in a different sizes with the different drying capacity, and the equipment is simple, or more thermal efficiency is there. Also drying capacity is more than the spray dryer, or drum dryer. Then it facilitates the drying of thermolabile substances, since the contact time of drying is very short. So this is also one of the important point. We can dry the thermolabile material. on this particular dryer, and it is a batch type or continuous type process. So it involves both batch as well as continuous. What is the difference between batch and continuous? Anyone? Anyone would like to share what is the batch process and what is the continuous process of drying? We have discussed this particular point. So batch process में क्या होता है, एक बार आप लोगों ने मटेरियल वहाँ पे फीड किया पर्टिकुलर ड्रायर में, फॉर एग्जांपल 5 kg of material, then you will give sufficient time for drying and then you will remove that material. So that is called as a batch. And continuously you have to load that particular material. जितना आप input करोगे उतना वो output आएगा. So that is the continuous process of drying. In batch mode में batch wise things are going to happen, whereas in continuous there will be the continuous input and output. So this is a major difference between the batch mode and continuous mode. Then in applications that you can say it is used for the drying of the granules in the production of the tablets, and it is used for coating of the granules. So major use of this dryer is in pharmaceutical industry, especially in tablet production, isn't it? So tablet बनाने के लिए क्या लगता है important? These are the granules. So for drying of the granules, better choice is about fluidized bed dryer, and it is also used to coat the granules. Isn't it? For coating purpose also, we can use this kind of dryer. Clear this point? Any doubt over here? Then we will talk about next dryer, that is about vacuum dryer. Isn't it? So this is a vacuum dryer. So this is a steam jacket, and this is a condenser. Then connection to the vacuum pump is there, and this is a condensate receiver. So this is the overall construction of vacuum dryer. Now in vacuum dryer, if you are talking about the principle of this dryer, the materials are dried by the vacuum. Major application as the name suggests. So the basic principle is about vacuum gets created, and because of that our material gets dried on vacuum dryer. So in a principle you can write this point. Also, therefore, what will happen? Due to vacuum, there will be the decrease in pressure, and therefore water boils at a lower temperature, and then the evaporation of the water takes place faster. This is the overall principle of this vacuum dryer, isn't it? What will happen due to the vacuum? There will be decrease in pressure. Are you agree with these things? We are creating any vacuum, so pressure gets decreased, isn't it? And once the pressure gets decreased, what will happen then? Water gets boiled at low temperature. And once the boiling of this water starts at a low temperature, then the evaporation of water takes faster, or evaporation of water will become fast, isn't it? So this is a principle of vacuum dryer. You are applying vacuum, obviously pressure will get decreased, water boils at a low temperature, whatever the material we are drying, and evaporation of water gets fast. In construction, you can see by considering the diagram, it consists of a heavy steam jacketed container made up of iron, and the closed chamber that consists of shells that are used to place the metal trays consisting of material. So all these things are the shells here in this steam jacket, isn't it? So you can keep the material, whatever we have to dry. and the shells provide a large area for heat conduction, isn't it? So as we are talking about heat and mass transfer, so here one more point we can add as a heat conduction, isn't it? So sufficient space is there for heat conduction as you are observing in this overall layout of this diagram. And the chamber is so strong to withstand under the vacuum, and the oven can be closed by a door. So the oven is connected through a condenser and liquid receiver to a vacuum pump. So oven is nothing but this is the steam jacket that is connected over condenser or maybe the this particular assembly. Then it condenser is there, connection to vacuum pump is there, and condenser receiver is there. What happened in now in working of this vacuum dryer? What one we can see in working? The trays that are generally present in the dryer are used to dry the material that are placed on the shelves, and the pressure is reduced uh, somewhat of moderate range by the vacuum pump. And so the door closes firmly and the steam passes through the jacket space and the shelves. So the heat transfer is carried out by the conduction mechanism. What is the mechanism behind this? Conduction mechanism. Isn't it? Because of this vacuum pump, the pressure gets decreased, and so obviously water gets passed over here on this heating material, and whatever things happen over here, that when the evaporating under vacuum, the water is evaporated from the material at 25 to 30 degrees centigrade, and the vapor goes to the condenser, isn't it? So after drying, the vacuum line is disconnected and the materials are collected from the trays. So this is the overall working pattern of this dryer. So exactly the major key point in this dryer, vacuum dryer, is creation of vacuum, isn't it? Whatever point we have seen over here, vacuum is applied over here, pressure gets decreased, and water gets boiled at a low temperature, and evaporation rate will become fast, and we can collect the material very easily on this vacuum dryer. So in advantages, we can always quote material handling is very easy. Then hollow shells, which are electrically heated, this can be used. Also, it provides a large surface area so that heat can be easily transferred throughout the body of the dryer and fast drying action takes place. Also, hot water can be supplied throughout the dryer, which helps in the drying process at the desired temperature. So these are the advantages. And in disadvantages, as you can always say, dryer is a batch type process, isn't it? So this is once the you are keeping sufficient material, you will give sufficient time for drying. You will remove this material, and again you will fill with the new material. So obviously, batch mode is one of the disadvantage of any kind of the dryer. Then it has a low efficiency, it is a more expensive, labor cost is high, need a high maintenance, and there is a danger of overheating due to the vacuum, because here we are applying the connection is there to directly to the vacuum pump. So there are high chances of overheating, isn't it? So that is, or these are the disadvantages of vacuum dryer. And in application, we can say vacuum dryer can be used for the drying of the heat sensitive materials, dusty materials, hygroscopic materials, uh, toxic materials, or maybe the feed materials containing the solvents, drugs which are required as a porous end products and are for the friable dry extract. So these are the points you can write in applications, especially the heat sensitive materials, isn't it? We can easily dry heat sensitive materials with the help of vacuum dryer. Clear this point? So in freeze dryer, next dryer
Sir,
is
can you
about
please repeat the advantages?
yes, yes,
Sir, can you please repeat the advantages?
yes, yes, yes. In advantages of this vacuum dryer, you can mention 3 to 4 points. That material handling is easy, isn't it? Because hardly steam jacket is there, trays are there, you can keep the material. So handling part is easy of this dryer. Then shelves are there, isn't it? Which are electrically heated. That can be also used over here. So that assembly is somewhat user friendly. So assembly we can say that is user friendly, and it provides large surface area. जितना आप surface area ज़्यादा दोगे उतना drying अच्छा होगा, isn't it? So this dryer provides large surface area, and because of this large surface area, heat can be easily transferred throughout the body of the dryer, and fast drying action takes place. That is one of the major disadvantage. And fourth point, we can mention that hot water can be supplied throughout the dryer, which helps in the drying process at the desired temperature, isn't it? So that provision is there. So obviously, you can supply continuous hot water for the better efficiency. These are the 3 to 4 points we can add as a advantages of these dryers. Okay. Then next dryer is about freeze dryer. You see the overall assembly of this freeze dryer. Just see now. You know what is a vacuum dryer. You know what is a fluidized bed dryer. Now you can only tell me what is the difference between these two dryers, and in what way the principle of this dryer will be differ as compared to the other two dryers. Just see. These are the frozen substance. These are the heated shells. Door is there. Drying chamber. This is the drying chamber. Then heat transfer of fluid manifold. This is the to vacuum, or maybe this is the isolation wall over here, and this is the refrigerant, and this is a condenser is mounted over here. So freeze dryer, always short note will be there. Write a short note on freeze dryer. What are your pointers then? In what way you will write the answer? First of all, diagram is necessary, block diagram. Then you will talk about principle of this dryer. Then second point, you will mention about construction part, or maybe what is assembly. This is the construction part. Then overall working of this dryer. Then advantages. Then disadvantages, and pharmaceutical applications, or maybe applications. So these are the 7 points needed, isn't it, to write kind of questions on any dryer. Maybe question will be the write a short note on drum dryer, write a short note on vacuum dryer. So diagram you should know. If you know the diagram, so obviously you can write all these points. There is no need to mug up the thing. इसमें principle क्या होगा? If you know the diagram and if you understood the concept of drawing terminology, so this topic gives you 100% marks, isn't it? As per his weightage. So in principle of this dryer, freeze dryer, we can say freeze drying, or what is the synonym for this freeze drying? There is lyophilization, isn't it? You can note down this word lyophilization. So what is this freeze drying or lyophilization? It is a drying process only used to convert the solutions of labile materials, isn't it? Or I am just writing over here solutions of labile materials into solids. But what will be the nature of that solid? Yes, having sufficient stability for distribution and storage. Stability is needed. Lyophilization or maybe the freeze drying, this is the process that converts solutions of labile materials into the solids of sufficient stability for distribution and storage. Clear this point? So in principle, we can say the main principle involved in lyophilization is called as which phenomena, sublimation. Do you know an example of any material which defines terminology sublimation? Any one of you?
Camphor.
Camphor, that's perfect. Who told Yashvi? Who answered this?
Didn't see.
Jinsi. Very, very, very. Yes, sublimation, well-known example is about camphor. So we can give thought in that way. While writing principle of this freeze dryer, which are the keywords or which are the key points that I should keep in mind? You have to just keep one word in your mind, that is sublimation. The main principle involved in freeze drying or lyophilization is sublimation. So the water passes directly from the solid state, that is ice, to the vapor state without passing through the liquid state, isn't it? So, as you know, sublimation, that is the solid state to directly vapor state. One more phase is the liquid phase, isn't it? Here in between. So, in sublimation, this process will not occur directly from solid to liquid. Sorry, solid to vapor, isn't it? Solid state, for example, ice to the vapor state without passing through the liquid state. Water is removed from the frozen state material and then subjected to the high vacuum to heat by conduction or radiation or by both, so that the sublime frozen liquid leaving only the solids or the dry components of the original liquid. So drying is achieved by subjecting the material to temperatures and pressures below the triple point of this particular component. Clear this particular point? Any doubt over here? So in construction, you can always mention that the freeze dryer consists of drying chamber in which the shelves are used to place the material. So these are the shelves we are using, isn't it? You are observing this diagram. So these are the shelves. Then heat supply is in the form of radiation source by using the heating coils. We are using the heating coils here, and because of that, see these are the because of the heating coils which are surrounded in this particular shelves, the compound or the material gets dried over here. So it is supplied through the radiation source, isn't it? And the condenser is also attached. Condenser consists of large surface cooled by the solid carbon dioxide slurred with acetone or ethanol, and the condenser surface should be cleaned properly. The purpose of the condenser is what? To attract the vapors being sublimed off of the product. And because the condenser is maintained at a lower over here, the condenser is maintained, isn't it? So if you are observing this, the condenser is maintained over here. So what is the role of the condenser? It is to attack the vapors being sublimed of the product. And because the condenser is maintained at a lower energy level related to the product ice, the vapors condense and turn back into the solid form in the condenser. So in a shelf freeze dryer, the condenser can be located inside the product chamber, that is called as an internal condenser, or in a separate chamber, that is called as an external condenser, connected to the product chamber by a vapor port. And the distance between subliming surface and the condenser, that should be less than in the path of molecules. And because this increases the rate of drying, the vacuum pump is also connected, which causes the evaporating or evaporative cooling. So the vacuum system consists of a separate vacuum pump connected to an outright condenser and attached product chamber. So this is the overall construction of fridge dryer. Now the overall working pattern. Generally, the steps are involved in this freeze dryer. Maybe preparation and pre-treatment is one of the important steps. Working, you can say preparation and pre-treatment. You can write over here. This is the first step. Second step, pre-freezing for solidifying water. For solidifying water, pre-freezing, isn't it? थर्ड स्टेप में क्या होगा फिर इन थर्ड स्टेप primary drying will be there, secondary drying is there, and the packing will be there. Primary drying and secondary drying. And the fourth point is maybe not vacuum over here. You can mention as a packing. Okay. So these are the four steps in working: preparation and pre-treatment, pre-freezing for solidifying water, primary and secondary drying, and packing. What can you add over here then in steps in freezing process? Uh, what will happen in first point? Anyone? Pre-treatment. What will happen in a pre-treatment? We can say it includes any method of treatment of the product before freezing, and this may include the concentrating the product, the revision of the formulation, that is the addition of components to increase the stability and or improve the processing, decreasing a high water pressure solvent, or increasing the surface area. Pre-treatment methods include what? Freezing concentration, solution phase concentration, formulation to preserve the appearance of the product, formulation to stabilize the reactive products, and formulation to increase the surface area and decreasing the high vapor pressure solvent. So that is called as a pre-treatment. In pre-freezing, second step, whatever we have written over here, that is pre-freezing for the solidifying water. Here what we can say, the product should be frozen at a temperature low enough to solidify completely. And since freeze drying is a change in the state from the solid phase to the gas phase, the material to be freeze dried must first be adequately pre-frozen. And the pre-freezing material method and the final temperature of the frozen product that can affect the ability to successfully freeze the material. So the rapid cooling results in small ice crystals useful for preserving structures that will be examined microscopically. But it produces a product that is more difficult to like then you can adjust the cooling pattern or cooling rate, even in a pre-freezing point. Also, in case of primary drying or secondary drying, so primary drying में क्या होगा after pre-freezing the product, condition must be established in which the ice can be removed from the frozen product through the sublimation, resulting in a dry, structurally intact product. And this requires very careful control of the two parameters. The first point is about temperature and pressure involved in the lyophilization system. Then the sublimation rate of frozen product depends on the difference in the vapor pressure of the product compared to the vapor pressure of the ice collector. Also, the molecules migrate from the high pressure sample to a lower pressure area. So, the temperature at which product is lyophilized, it is balanced between the temperature and maintain the frozen integrity of the product and the temperature that maximizes the vapor pressure of the product. So this balances is a key for the optimum drying. And heat enters the product by number of mechanisms, maybe by direct contact between the container base and the cell, or by conduction across the container base, base and then to the frozen mass to the drying front, or by gaseous convection between the product and the receiver in the chamber condition. So clear this particular point, preparation and pre-treatment, then pre-freezing for solidifying water, primary and secondary drying. So primary we have seen. Now we will talk about secondary drying. So after primary freeze drying is complete and all the ice has submitted, warm moisture is still present in the product. So the product appears dry, but the residual moisture content may be as high as 7 to 8%. So continued drying is necessary at a warm temperature to reduce the residual moisture content to the optimum values. Isn't it? So that is the role of secondary drying. Clear this particular point. Then packing. Last point is about packaging. Secondary drying also usually carried out for approximately maybe one third or maybe half the time required for the primary drying. Then fifth point is about packing. So in packing, we can say by replacing the vacuum with the inert gas, bottles and vials are closed. So that is called as the packing part. Then in advantages. In advantages of this dryer, this is a suitable for drying the heat sensitive products again. So we can mention heat sensitive product. Then freeze dried product is porous and easy to be rehydrated and instantly dissolved. So that will be the one of the advantage for kind of dosage forms. Then drying takes place at a very low temperature so that the enzyme action is inhibited and chemical decomposition, particularly the hydrolysis is minimized. Then denaturation of protein doesn't occur over here. Denaturation means what? Degradation pattern of the protein, isn't it? So that will not occur over here. Then loss of volatile material is less and sterility can be maintained in case of the this dryer. And in disadvantages, we can always quote the process is very slow and expensive process. It is not a general method of drying, but it is limited to certain types of valuable products that cannot be dried by any other means. The period of drying is high, that is also one of the disadvantages, and the product is prone to the oxidation due to the high velocity and large surface area. Therefore, the product must be vacuum packed or with an inert gas in a container. So these are the points we can add over here. The last point that we are going to talk, freeze dryer. that is about pharmaceutical applications of the dryer. So it is used in a production of injection, solution, and suspension. It is also used for production of blood plasma and in fractional products, bacterial and viral cultures, antibiotics and plant extracts, steroids, vitamins, and enzymes. Food items like mushrooms, maybe the prawns, meat products can be dried by this freeze drying method. And coffee and tea concentrates and citrus fruit juice are also dried by this particular method of freeze drying or lyophilization. So clear this particular point, whatever we have covered in this topic. Yes, any doubt over here? So in examination, the pattern of the question will be there, isn't it? So hardly we have a tray dryer, drum dryer, then spray dryer, fluidized bed dryer, and vacuum dryer. And you have to study all these dryers based on some pointers, and these pointers are principal, construction, working, advantages, disadvantages, and pharmaceutical applications of these dryers. Okay, and some terminologies, whatever we have seen earlier. Suppose I am asking you some definitions. Define drying, or maybe define unbound water, or what is equilibrium moisture contained. Then what is hot, or maybe how moisture content is measured. So maybe these are just some expected questions from this particular topic. Also, suppose I am asking you a question over here, how to measure the rate of drying. You should know the answers of that. Then write the difference between drying and evaporation. Or what are the desorption and sorption? This is also one of the important questions. Then how equilibrium moisture content is determined, or what is the importance of equilibrium moisture content data. Then how to measure the rate of drying, or how to measure the loss on drying. Or maybe long answer questions will be there. Explain mechanism of drying process. Also explain drying rate curve. Then principal construction, working uses, merits and demerits of tray dryer, drum dryer, spray dryer, fluidized bed dryer, vacuum dryer, freeze dryer. Then write detailed note on application of drying or steps involved in a freeze drying process. So obviously these are the some important questions over here, isn't it? So any doubt over here as of now, whatever we have covered, drying topic. So I think that's all from the topic drying. Then in the next class, we will go with a new topic that is called as centrifugation. Centrifugation is also one of the very interesting topic, and the concepts are very easy to understand. And on a similar line, we can work. Some introduction part will be, then the various instruments or the equipments that we are using for centrifugation that we are going to talk. Okay, so that's all in today's class. Then see you in next class on a new topic. And most probably we will take some MCQ kind of test.
Yes,
Then
sir.
multiple choice questions we can keep over here on drying topic. 10 questions I will just take, and based on that you can reflect as a kind of assignment we can say. Yes, any specific question?